Hello, I'm Frank. Today we're going to learn how to factor expressions of the form ax squared plus bx plus c is equal to 0. Is ax squared plus bx plus c where a is not 0. Now today's assignment is going to be a review assignment of the types of factoring. We're going to break this up into two parts. This will be part 1. We have 6 examples, and then we'll follow up with part 2, which will be 6 more examples. So this is a summary of the different types of factoring. So each one is a little different. Okay, our first example is y squared plus 14y plus 13. So in all these problems, there will be no GCF, which is the first step we look for. There's no greatest common factor. So in this example, we're going to open up 2 parentheses. And we start out with y times y, and that'll give you your y squared. Now, this sign being positive tells you that the signs are both the same. It's either a plus times a plus or a minus times a minus. Now, this sign being plus tells us that it will be the plus and the plus. So once again, if this sign is positive, these 2 signs are both the same. And what they are is this sign. So they're both plus. Now, we need 2 numbers that multiply to 13. So when you add them up, you get 14. Well, since 13 is a prime number, it's only one set, 1 and 13. So you can put the 1 here or the 13 there, whichever you choose, and you put the opposite here. Now, I encourage you to always FOIL your answer to see if it's what you get, or multiply it, whatever you choose. This would be your y squared. This would be 1y plus 13y, and that gives you your 14y, and 1 times 13 is your 13. So that's one of the most basic types of quadratic factoring. Okay, our second example. Once again, there's no GCFs here. So we start off with a t and a t. Now, recall that this side's plus means they're both the same. These 2 are either plus plus or minus minus. This sign tells you what choice it is. So it's minus minus. Now, 24 is not prime. It can be multiplied numerous factors. You could have 1 times 24. You could have 2 times 12. You can have 3 times 8. You can have 4 times 6. So which one do you choose? Well, you need 2 numbers that multiply to 24, that when you add them up, you get 11. Well, you can experiment, but you will eventually come down to 3 and 8. Now let's check that. Here's your t squared. This is negative 3t and negative 8t. So negative 3 plus a negative 8 is negative 11. And this is your 24. So there's your second example. Okay. Our third example, sometimes this confuses students. They're so used to seeing the square term first. So I want to show you 2 approaches to this problem. Notice the numbers first. Usually polynomials are in descending order. That's the way we like it as teachers. But this one's in ascending order. The exponents are going up. So let's just factor it the way it is. Now, these 2 numbers are both pluses. So that means the signs are going to be the same, and that's what they're going to be. and we need a and a at the end. Because that'll give you a negative a times a negative a is your a squared. Now we need two numbers that multiply to 54 that combine to 21. Well, there's 1 in 54. But if we combine them, it's 55. There's 2 in 27. If we combine them, we get 29. Okay, there's 3 and 18. Aha, if you combine 3 and 18, you get your 21. So you could put the 3 first if you choose, and the 18 second. Now let's check. There's your 54. Here's negative 18a and negative 3a. Negative 18, negative 3, negative 21. And negative a times negative a is a squared. Now, another approach for this is to rewrite it. So if you were to take that problem again, and rearrange the order, a squared minus 21a plus 54. And frequently students do this because they get in their comfort zone of something that looks familiar, and then factor it, a and a. This sign's plus, so that says these signs are the same, and that's what they are. And 18 and 3. And there it is again. A squared minus 3a minus 18a, which is that. And negative 3 times 18 is 54. Now, if you look at those two boxed answers, they do look differently, but they are the same. So a lot of times students who go this route to get in their comfort zone of putting the square first, they will have this answer. Now, on a multiple choice assessment, if the problem's written like this, chances are it'll be in this form. So you have to recognize that they are equivalent. Okay, our fourth example is two variables. No different. We just have a p there. So we have n and n. This sign's positive, meaning these signs are the same. They're either plus plus or minus minus, and that's what they are. Now, two numbers that multiply to 35 that add up to 12. Well, that's 5 and 7. Now, frequently I'll have students put 5 and 7 because they see that 12. They say, I got it, but I'll tell them, what's 5 times 7? They'll say 35. I say, yes, but how about that? Oh, I need to put a P and a P. And I say, yep. Now that's it. N squared, 5NP, 12NP, 5NP, 7NP, which adds up to your 12NP. And 5P times 7P is 35P squared. So there it is. Okay, our next example, somewhat the same. We have S and S. This sign tells us they're the same. These two are either plus plus or minus minus, and that's what they are. Two numbers that multiply to 18, that would combine to 9. Well, there's 1 and 18. That's not going to do it. That's 19. There's 2 and 9. 2 and 9 would be 11. How about 3 and 6? If you put the 3 there and the 6 there, that'll give you your 18. But you need t squared. So we put a t there and a t there. Let's check. S times s is s squared. This gives you negative 3 st and another negative 6 st, which adds up to negative 9 st. And negative 3t times negative 6t is 18t squared. So there you go. But then our last one is similar. That 52 could be a little bit harder to find the factors of. We'll try. We have a and a. Okay, this is negative. That tells you one's plus and one's minus. Now, since they're different signs, we need two factors to give us 52 that subtract to 9. Where's 1 and 52? Without one do. Subtract, we get 51 or negative 51. There's 2 and 26. No, that won't do it either. You subtract them and you get 24. Okay, so we need to find them. So let's find 4 and 13. And the way I do that is I just double the 2. 2 times 2 is 4. And if you double this one, you got to take half of that one. You counteract it. So you double this 4, take half of this, 4 times 13. And if you subtract 4 and 13, you get 9. So you're going to have 13 and 4. Now, if you randomly put it like this, which sometimes I've seen, I'd say, wait a minute. That'll be 13, and that'll be minus 4, which is positive 9. You need negative 9. So let's make this negative and this positive. Now that'll give you your negative 9, but you need to get the b in there. So we put the b and the b. Now let's check. A squared minus 13ab and 4ab. Well, negative 13 plus 4 is negative 9. And then the latter terms are negative 52b squared. So there is our last example for today. Now our follow-up, which we're going to call part 2 on this, we're going to factor difference of squares, perfect trinomial squares, and then a combination thereof. So stay tuned for our next one. But this will get you started on your first part of your quadratic factoring review. Okay? Stay tuned. Take care.